Okay, today's video is going to be on the remainder theorem and the factor theorem. I'm going to focus mostly on the remainder theorem. Just to start off, here's a polynomial that you probably can factorize yourself. So it's got two factors, x minus 2 and x minus 3. And we're just going to look at this again using long division to find out what would be left over if I divided by one of these factors. We're going to use long division. If you don't know how to use long division, then just try and follow it and just look at the result of the division. I'm going to make a video of it later. There's also synthetic division, which does the same thing. I don't really like synthetic division. I don't think I'll use it. It's just, I mean, by its name, it's not really natural. It's not as good to look at as long division. It's not as pretty as long division. I think that's the nerdiest thing I've ever said, if I called long division pretty. Anyway, let's move on from that. If I want to divide by x minus 2 using long division, then I'm just gonna, how many times does x, the first part of it, go into x squared? It doesn't with an x squared coefficient. It goes in x times, so x times x is x squared, minus 2 times x is negative 2x. We'll just subtract that. Alright, and that's going to leave us with no x squareds anymore, minus 3x plus 6, that comes down. Same again, negative 3 times x gives you negative 3x, which gives you negative 3x minus 6. We'll subtract that again, and we're left with 0. So that's our remainder. Our remainder is 0. Therefore, if you divide something you get remainder 0, then the thing you divided by has to be a factor. For instance, here's number 16. If we took all the factors of 16, one of them is 8. If I divide 16 by 8, I get 2, with nothing else, no remainder. So 8 is a factor of 16, but 5 is not. 16 divided by 5 is 3, but it gives you 1 left over, so the remainder is 1. That's in essence what we're doing here, but we're doing it with polynomials. We're doing it with bigger things than just single numbers. So here's our one from before, x squared minus 5x plus 6. And just a reminder, here's our two factors. What if I tried dividing it by something which isn't a factor, like x minus 4? What is the remainder going to be? Just using long division again. Bear with me for this, by the way. I'm going to show you a better way, which is the main point of this video, so just follow through with this. If I take the highest coefficient as x, we'll subtract that, then we're going to get left with x negative x plus 6. It's going to repeat again. Now remainder is 2, which is not equal to 0. So we know that well, first of all, we know that x minus 4 is not a factor. And our remainder is equal to 2. Right. So here's the factor theorem. If we've got a polynomial of x, some function of x, for example, r1 is x squared minus 5x plus 6, so that's our polynomial of x. And we divide it by some linear term, x minus a. For us it was x minus 4. And I want to know what's the remainder. Well, the remainder is going to be equal to, if I take a and plug that into the function. So x minus a, for us it's x minus 4, so a has to be 4. So I'm going to write my polynomial again, but everywhere I see an x, I'm going to plug in the a value of 4. So it's going to be 4 squared minus 5 times 4 plus 6. And that's going to give us 16 minus 20 plus 6. That's going to give us 2, which is what we got in the last one, using long division. So instead of doing all that long division stuff, we can just use our remainder theorem, which is this one here, and we don't have to do long division. We can just jump straight to the remainder by plugging in a into our polynomial. Let's just make this a bit clearer. Here's an example. Let's do another example. So I want to know what is the remainder when I divide this polynomial, x to the power of 3 plus 5x squared minus x plus 6, when I divide it by the term x plus 1. Well, we have to know what is x minus a. Well, we've got x plus 1, so x minus a, let's equate that. A has to be negative 1. So all I have to do is, everywhere I see an x, I'm just going to write minus 1, because that's what a is in x plus 1. So everywhere I would have seen an x, I'm now going to put negative 1. Oh, I forgot my squared value. So that's just going to all work out to be 11. So as easy as that. No long division. We just know our remainder is going to be equal to 11. Alright, same example, slightly trickier. This time the thing we're dividing by has a 2 in front of it, so it doesn't look like x minus a, but easy solve is just to divide everything by 2. So now we've got x plus 3 over 2. We have to make that look like x minus a. A is going to have to be negative 3 over 2. Once again, plug it in. Everywhere you see an x, just plug that in. Minus 3 over 2. And that's, oh, I forgot my squared. That's going to equal 15.375, and that's your remainder. So that's all remainder theorem is just showing you a quick way to find the remainder when you divide a polynomial by some linear term. So we're going to talk about factor theorem, which is just a special case of the remainder theorem. So here's our quadratic that we started at the beginning. We're going to divide it by x minus 2. Just a reminder, x minus 2 and x minus 3 were the two factors. Okay, and we did this with long division, but I'm just going to do it using remainder theorem. So a is equal to 2. I'm going to take 2, I'll plug it in everywhere I saw an x. That's going to give us 0. So all factor theorem is the remainder theorem. When the remainder is 0, therefore you can show that your x minus a, whatever it was, x minus 2 in this case, is actually a factor. So if you try the remainder theorem and you get the remainder is equal to 0, then you've proved what you're dividing by was a factor of your original polynomial. So if p of a is equal to 0, the remainder equals 0, it's a factor.